Okay, let's look at number 14 in section 9.1. The following data are based on information from domestic affairs. Let X be the average number of employees in a group health insurance plan, and let Y be the average administrative cost as percentage of claims. Part A says make a scatter diagram and draw the line you think that best fits the data. Part B says, would you say the correlation is low, moderate, or strong, positive, or negative? Part C asks you to use the calculator to get these sums. Most of the time we don't need the sums to compute R. The calculator is going to give it to us, so I'll show you that. As X increases from 3 to 75, does the value of R imply that Y should tend to increase or decrease? All right, so R that we're calculating is our correlation coefficient. So in Part B, I just want you to look at your line and say what you think it should be. And then in Part C, it wants you to actually calculate R. Okay? All right, so when we look at the data on our graph, the first one was X is 3 and Y is 40. So we have our X scale here, and it told us that X was the average number of employees in a group health insurance plan. So one of the most important things we have to do is label the axes. Okay? It tells us Y is the average administrative costs. Okay? As a percentage of claims. Okay? When you're doing graphs, the two important things you have to do is label the axes and put a title. Okay? The other thing is your scales have to be to scale. So if you're starting here like at 50 instead of 0, I want 0, 5, 10, you need a broken axis. Okay? So remember those graphing important things. So the first point is 3 and 40. So 3 is about here, 40 is here. The next point was 7 and 35. And then we have 15 and 30. And then we have 35 and 25. And then we have 75 and 18 way out here. Okay, so mine's kind of going off the page. You might want to do your scale a little better. But you can see there is a trend that it's decreasing in this direction. Okay, so remember the scatter diagram is going to give you an idea of what your data is doing. It does appear to be a linear trend that it's going down. So I would say, you know, it's not real strong, but it is a moderate trend. So in Part B, I believe I would say it is a moderate, and it's going as X increases, Y decreases, right? So it's a negative correlation. So I would give it a moderate negative correlation. Okay, so let's see what our R comes out to be. So in our calculator, we want to go into Stat, into Edit, and put your X values in L1 and your Y values in L2. Then in our calculator, we're going to go back to our favorite button, Stat. Instead of going to Test, we're just going to go to Calc. Okay, and number 4 says linreg AX plus B. We're doing linear regression. And if you watch the lecture videos, the linear regression is part of inferential statistics that helps us predict data values. So when we did confidence intervals, we were estimating those population parameters. When we did hypothesis testing, we were making decisions about those population parameters, and now we are predicting. Okay, so if we go down to number 4, linreg, hit enter, I'm going to tell L1, comma L2, because my X values are in L1 and my Y values are in L2. Okay, now on your calculator, it's going to give you your equation, your regression equation, and it's going to give you the slope. And if you look at AX, in my example, A is my slope, and it's a negative slope. B is my y-intercept. So you need to know something about graphing from if you took 0903 or if you had a prereq other than that prior to getting into statistics, you should know what the negative slope means and the y-intercept. Okay, now our calculator will also give us the r and r squared. We'll talk about r squared in the next section, but the r, again, in this section is the coefficient of correlation. Okay, now you only have to do this one time on your calculator and it will stay on. But if, for example, r didn't show up, some of you maybe it did show up. But if it didn't, if yours showed up, you don't have to do this. Go to catalog, which is above the 0 key, and you're going to arrow down until it says diagnostic on. You could type in D, I believe, as well. But okay, diagnostic on. And when that comes up, just hit enter again. It'll say done. I'm going to hit second, enter twice, or go back into Stat Calc LinReg. Hit enter. And do you see what happened? Instead of just the A and B, now I have r squared and r. Now again, once you turn it on, unless you reset your memory, it will stay on for all of chapter 9. So you can see my r is the last. It gives me r squared, but it also gives me r. It's negative 0.945. So in this section, what they show you is the sums and how to calculate this using the formula. But again, my calculator gave it to me. So you want to remember, the closer that r is to -1, the stronger the negative correlation. The closer it is to +1, the stronger the positive correlation. And the closer it is to 0 means there really isn't much of correlation. Okay? So looking at this, these pictures here in your textbook, you can see this is really no linear correlation, so your r would be really close to 0. Okay, in this picture, r would, if the points fell exactly on the line, it would equal -1. Here would be +1. This is a negative slope, positive slope. And this is more like real life data. If it's getting close to a positive slope, okay, our r is going to be close to 1. Here our r would be close to -1. In this picture, it would be closer to 0. So that's really what you're looking for, the strength of that correlation. And ours, you can see it was negative 0.944, which is, I had said moderate, but it's really a pretty strong negative correlation here.